When you write conditional statements, one of the things that you often have to do is to compare values. Now, in the earlier videos, we just kind of assumed that we could do this. In fact, when we were writing our code here, we spoke in English saying if age is less than 21, and we typed that in using a less than symbol here. And it just so happened that worked inside of Scala. But not all of the comparison operators are going to be exactly like what you might expect them to be, and so it's worth taking a few minutes to talk about exactly what the different comparison operators are in Scala. So one of the things that you might want to do when you're checking values is to see if two values are equal. And it's tempting to think that we would do it like this, but it turns out that doesn't work. The single equals is what we use here for assignment. And in fact, if we run this, we get an error message. First it says reassignment to val. So it's basically saying, yes, this is trying to do an assignment. It's not doing a check for equality. Even if I change this to a var, I get a different type of error message. It says type mismatch, found unit required Boolean, because assignments give you back unit. They don't really provide you with any information. And anything that you put inside of an if has to be a Boolean. Okay, so basically what we can say is this is not how you check equality. To check equality, Scala uses a notation that it gets from the C family of languages, and that is to use equal equal to check to see if two things are the same. So a single equal is an assignment, a double equal is a check for equality. And of course, the way I've written this, the only way that it will say get lost is if I happen to put in exactly 21. And if I put in any other value, it'll say come in. Okay, so that's equality. What if I want to say if two things are not equal? Well, the syntax for that is a bang equal, or an exclamation point equal. This also comes from the C family of languages, and basically the bang symbol is used to represent not in the C family languages. So using that, here again we can run this, and it will only say, well, now if I put in any number other than 21, it says get lost, and if I put in exactly 21, it'll say come in. Okay. We've already seen that less than works that way. It turns out that greater than works that way, and just less than or greater than, you have those symbols on the keyboard. It's simple. But what if I want to do less than or equal to? Well, in math you would have written the less than with a bar underneath it. I don't have that symbol nicely on my keyboard. Instead, I type it in much the same way that you would say it. I type less than or equal to, and now that does what it kind of reads as. The order here matters. If you do equal less than, that's not the same, that's not happy Scala. It won't like that. So you have to do less than or equal to. Just remember that you're going to type the symbols in the same way that you say them. Similarly, if you want to do greater than or equal to, it's greater than equal to. Okay? Just the way you would say it. You can't swap them, you need them to be in this order. Okay, so that covers the basic assignment operators. Anyone with a background in Java will be familiar with the fact that this equal equal operator doesn't always do exactly what you were expecting in Java. It actually does what you expect in Scala. So if I have two values and I use equal equal, it checks to see if the values are equal to one another. There is another way of comparing two objects. In an earlier video, we introduced a mental model for declaring variables. And in that mental model, you kind of have a named box that points to, it refers to an object. So what the equal equal does is it takes those two objects that are referred to and it checks them against each other to see if they are of equal value. And if they are, it returns true, otherwise it returns false. Sometimes you actually want to know not if they are two objects with the same value, but you want to know if they are the same object, and that is called an identity check. So instead of checking for equality, sometimes you want to check for identity. In Java, the equal equal checks for identity. And we can kind of illustrate this by making two strings. So I'm going to make an S1 and an S2, and it's tempting to do this, but it turns out the compiler is too smart. So I'll say if S1 equals S2 print line equal, else print line not equal. Okay. This code actually does exactly what we expect. I give it an age. It says equal because those two things are equal. If I wanted to check for identity, I replace the equal with an EQ. Okay, and this will actually do an identity check. We'll check to see if they are the exact same object. Now it happens that in this case they are. And the reason for that is because the compiler is doing work up front, and it builds this string, and then it actually builds this string before the program runs. It realizes they're the same thing and decides to make them equal to the same object. We can prevent that from happening by, instead of having it be high, we can put a read line here. And so now I can type in whatever I want. Now, of course, if I type in 42, they're not equal. They couldn't be possibly equal. They couldn't be the same object because one of them is high there and the other one is 42 there. But even if I type in high and a space, it still says that they are not equal in the sense of EQ. However, in the sense of equal, high and a space, they are equal. So I can have two strings that have the same value in them, and equal compares them. If you want to check identity, if you want to see that they're the exact same object, you use EQ instead. But most of the time that isn't what you want to do. Most of the time you want to check for equality, and so most of the time you're going to be using this equal operator for doing your comparisons.